Hi everyone. Today I'm going to talk about 1.6 Math 180 Business Calculus. This session talking about average rate of change and instantaneous rate of change. For the average rate of change, I have talked a little bit in session 1.3 with slope and average rate of change. So the average rate of change is I can say like a slope of the curve, but like a slope between 2 points on the curve. So as you see in the figure in the right hand side here, I have 2 points, say point A and B. One is according with the coordinate as x1, y1, the other is x2, y2. So I will have the average rate of change, AVRC, will be the same as the slope of the line go through 2 point A and B, which is y2 minus y1 over x2 minus x1. And in another way to write, the form should be fx2 minus fx1 over x2 minus x1. This for this form, I did explain you in 1.3 already, so you can review that, or I actually remind you already. Make sure I mean, in this session, you're going to learn about two versions of the average rate of change. The first one is this one, this form. And remember that you only use this form if you know the coordinate of 2 points, okay? So in this case, you know the coordinate of 2 points, A and B already. So you want to apply this form. For the other case is, if you just know only the initial value of x, so say here is initial point, okay, and then and you just know how much it changed. You just know the amount of changing with each age in here, like it's moved from the initial x here to the point x point h. So you have to use another version of the average rate of change, which is fx plus h minus fx over h. And as you can see that this this actually is similar with the form with the version 1, but you know, like I say, in this case, I don't even need 2 value of x. I just need only 1 value of x here for the initial one, and I need the h, which is different, which is amount of change from the initial to the final value of x. So when you simplify for the bottom, you're gonna get only h, which is different between the initial value and the final value of x. Okay. So let's do some example. This should be go together with example 3 here. All right. And now let's talk about number 2, example 2 in the text. A college bookstore sells mechanical pencil for which it pays $1 for each. Okay. The manager of the bookstore feels that if the selling price is X dollar each, okay, she will sell 12 minus X pencil each week. The bookstore has fixed cost of $10. The function relating profit P and selling price is Px equal to x squared, negative x squared plus 13x minus 22. And the requirement for the x and is from 2 to 11, okay? And remember that x in here is what? Is the selling price, okay? selling price. All right. Now, what the question? The question is find the average rate of change of the profit. Okay, and with the respect to the selling price is if the selling price change from $3 to $6. So what does that mean? I mean, I give you the initial value is x1 is $3 and the final value is x2 is $6. And as you see in the figure down here, I have the graph of the price respect to the selling price x. Okay. So average rate of change actually equal to the change in profit over the change in the price. Or in this case, you actually need to use the version number 1 because you know both of the value, both the value of x initial and x final, right? So I'm gonna write as average rate of change going to be equal to y2 minus y1. I mean, let's change this now because you are using f of x2 minus f of x1. You can use y2 minus y1, but I just want to write like this, so people can know that that is average rate of change instead of just say slope. So x2 minus x1. Thing in here is I haven't know the fx2 yet, and I haven't know the fx1 yet. So let's find it. Okay, move down, and I have fx2 will be equal to what? X2 is $6, right? So I have actually this is not f, this is p. I should change it to p because this is a function stand by p. So let's change this p. And I have a p of x equal to negative x squared plus 13x minus 22. So I change x becomes 6. So the negative 6 squared plus 13 times 6 minus 22. And I will have what p of 6 will be equal to let me use my calculator. Okay, so let's use calculator. I have negative 6 square. Oh, actually, if I use like that, maybe that's going to be problem. Okay, let me change it a little bit. It's negative, and then 6 square plus with 13 times 6 minus 22. So I'm gonna have 20. Okay. So this is 20. And p of x1 will be equal to p of 3 equal to negative 3 square plus 13 times 3 minus 22. And then p of 3 will be equal to negative 9 plus 39 minus 22. So that's going to be what? I'm going to have 30 minus 22 is going to be equal to 8. So maybe I'm going to write like this. P of 3 equal to 8. Okay, and then now I'm gonna just substitute everything to get the together, the average rate of change will be equal to P of 6 minus P of 3 divided by 6 minus 3, and that will be equal to P of 6 is 20 minus 8 over 3, and now it's going to be 12 over 3 is equal to 4. So that's going to be the answer. So let's move to the example 3 here, and this number 3 is still find the average rate of change of fx with respect to x on the interval. But in here, the fx is a piecewise function, and the interval is from 95 to 2. What does that mean? That means that x1 equals to -5 and x2 equal to 2. Okay, so now I need to because this give me two value value of x, so I can just using the version number 1 of the average rate of change, and I need to find f of x1 and f of x2. What is that going to be? F of x1 is f of -5, and I will plug into the function fx. But in this case, I need to know that since x1 equals to -5, which part of the piecewise function that I should use. So you have to check both of these part, which part that include the -5. I noted that the first one here is the one that you may think about, and then because why? Because you have -5 here, right? And then you're gonna just plug into the first part of the fx. Okay, so it's gonna be 3x squared. Now x squared become -5 squared, and then plus -5. Let me change this 5, and then plus 3. So now you will have 3 times 25, 3 times 25 minus 5 plus 3. And then you will have what? Let's use calculator. You have 3 times 25 minus 5 plus 3 is minus 2. You have 73. 73 is fx1. Okay, so now for the other case, f of x2, you have x2 going to be f of 2, and since x2 equal to 2, then I have to check which part of the fx of the piecewise function I should apply into. In here, 2 is lying on the second part, which is this guy, which is the second function here. So I will apply into that expression, which is 2 minus 4, and that's going to be equal to -2. And that equal to fx2. And now I will just substitute all that thing into the average rate of change formula, version number 1. So fx2 minus fx1 over x2 minus x1. Why I put x2 here? Okay. Now I'm gonna have fx2 is -2 minus fx1 gonna be what? 73. and then I divide by x2 is 2, and minus for x1 is -5. Okay, don't forget to put the negative, okay, because sometimes you guys just try to combine or maybe even forget the negative sign, and then that's change all the answer. Now you're gonna have -75 over what? 2 minus, no, 2 plus 5 will become 7. So this should be the answer for the average rate of change. I don't need to, you can change it to be decimal, but I don't want to do that. Okay. So now let's move to example 4. In example 4, for the function of fx equal to x squared, negative x squared plus 13x minus 22, what is that function? Is look like the function of px in the example 2. Let's see. Find and simplify the different quotient fx plus h minus x over h. Notice that it is the function we examine in example 2. See, exactly that it is a function in example 2. So and I want you to notice that this different quotient is actually the average rate of change in version number 2. In the version number 2 form. In this case, it doesn't tell you anything about the X initial, and the X final. So I'm gonna call this like the average rate of change in general form, or the version number 2 form. When you apply in that, you will not get to maybe you will not get rid of the variable, but let's see for this case, and how can I do that. So I have fx will be, I will rewrite fx equal to let me see, f of x equal to negative x squared plus 13x minus 22. And I would like to change it to be red color. And then now I want to say f of x x plus h. So remember that now is x plus h is input. So you have to change all the x above to be x plus h. Now I have negative of x squared, right? So the square plus 13 times x minus 22. Now I change all that to be x plus h, x plus h, right? And now, since you have like a complicated expression here, so I would like to simplify it by distribution for this square. Let's see, I have negative of x plus h times x plus h plus 13 gonna be times x plus h gonna be distribution to be x 13x plus 13h and minus 22. Okay, so move this down. I'm gonna have minus of x squared plus 8x, and then hx, or x is the same, plus with s squared, right? And then I'm gonna plus with 13x and plus with 13h minus 22. Remember that I still have to consider for the negative at the before the the x per s times x per h here, and then I will distribution that's going to be change all the sign in the inside the parentheses, negative x squared minus 2x because I can combine the two. So 2sx and minus s squared, and then I have plus 13x plus 13h minus 22, and then this should be the form of x per h for these columns, and I need this for later to plug in, so I'm gonna circle it, okay, because it's important to me. All right, and now it's time to plug into the top of the different quotient, which is f h plus h. And I know that's maybe some of you gonna just write all the form of the different quotient, but I would like to do like step by step. So I just simplify the top first, because I don't have to. I mean, I don't want to mess up with forgetting the bottom later. So I'm gonna do just the top here first. Okay. So you can do that, but I think this is the best way. Okay. So now I'm gonna plug in. I'm gonna substitute fx per h. Let's have parentheses to make sure I don't forget anything. So this is negative x squared minus 2x minus s squared minus plus 13x and plus 13h and minus 22. And then I minus for the fx. Fx is top here, and I still have to have parentheses, negative x squared plus 13x minus 22. And I'm gonna open all the parentheses to get to see what happened. For the first one, I don't have to worry about the sign. It doesn't change anything because it doesn't have any negative in front of the parentheses. So I keep it. Okay. And then the second one have a negative in front of the parentheses. I'm gonna change all the sign after the parentheses. So plus x squared minus 13x and plus 22. So now it's time to simplify or combine like term. I have positive 13x and negative 13x gone. I have negative 22 and negative, positive 22 gone. I have negative x squared. I have positive x squared is gone. Okay, I think that is enough to simplify. So I'm gonna get negative 2x minus s squared plus 13h. And before I get in, before I plug back to the different quotient, I noted that at the bottom of the different quotient here, I have an h. So I would like to factor the h out, so later I can cancel the h, right? I want to factor the h for the top. Okay, and then inside here I will have I put the 13 first because it's positive, and then I minus for 2h and minus for not 2h, minus for the 2x, and then minus h. Okay. Okay, now you can circle this to make sure you don't forget it. This is what it is: fx plus h minus fx. Okay, and now substitute time. You have fx plus h minus fx and divided by h. This will be equal to what? H 13 minus 2x minus h, right? That is top. Bottom is h. And then since it's since it's factor everything already, you can cancel for the same factor between top and bottom, and you will have 13. Oops. You will have 13 minus 2x minus h, and just be note that h in this case has to be not equal to 0, because if it's not equal to 0, then this is undefined. Okay, and again, this is I can oh, this is the answer for example 4, and I can say this is like a general form for the average rate of change, but you don't know what is initial value, and you don't know what is the amount of change h in here. Okay, and the interpretation for this is the average rate of change of fx equal to negative x squared plus 13x minus 22 with respect to x is given by, okay, so this is the form that they just use negative 2x first. Okay, that's fine, same thing. Minus h plus 13, and this, unlike the rate of change in example 3, this rate of change depends on both the initial value of x and the amount of change is h. Okay, so yeah, so that's done for this example, and let me do one more example, example 5 for you here. You can skip this if you feel like you're okay with that, but if you're still not okay, it is another example for you. So for the function fx equal to x squared minus 2x plus 1, and then I'm gonna find fx per h minus fx over h. Okay, so firstly, I'm gonna write fx down here equal to x squared minus 2x plus 1, and then I will write out f x plus h, right? Because I want it later equal to something square minus 2 times something square, something plus 1. And what is the thing? That is input x plus h, right? Okay, now I'm gonna find the top. So fx plus h minus fx. So that's gonna be, oh wait, I haven't simplified the fx plus h. So let's do it. So x plus h squared will be x squared plus 2xh plus h squared. This is a special square, completing square form that you may learn in correct algebra. Or if you forget it, you can just multiply between x plus s, between two factor x plus s and x plus s, and you're gonna have the same thing like this. And you minus for 2x plus h here to be distribution, so 2 negative 2x minus negative 2h plus 1, and you will get simplify that. It's gonna be what? You can simplify? I don't think so. So that should be fx plus h. Okay, and now it's time to substitute that. X squared plus 2xh, and then plus h squared minus 2x minus 2h plus 1, and then you minus 4 fx. What is fx? Fx is x squared minus 2x plus 1. Okay, remember that you should have the parenthesis before put out the fx. Okay, Now you need to open it. So x squared plus 2xh plus h squared minus 2x minus 2h plus 1 minus x squared plus 2x minus 1. Okay, so now it's time to combine that term, right? Let me see. For the x squared is to be gone. It has to be gone. Okay. Minus 2x is going to be gone. And 1 has to be gone. Okay. And you have to write out the simplified form as 2xh plus s squared and minus 2h. All right. And now I would like to factor the h out because why? Because the bottom, I see that the bottom of this form have h. So I need to factor h out so later I can cancel it. So h times 2x plus h minus 2, right? Okay, that is what? That is f fx plus h minus fx. Okay, and I'm gonna circle this. So I will now I will plug in everything. X plus h minus fx over h will be equal to h 2x plus h minus 2 over h. And I will cancel the h to get 2x plus h minus 2. And this should be the answer. So for this problem, but try to write it as h in this case not equal 0, okay? And it is average rate of change in general, okay? So keep in mind that always you have to have factor the h out in order to later you can cancel it. If you cannot, then there is problem that you may make a mistake, so you cannot factor the h out. Now let's move to the next topics. Now I'm gonna talk about instantaneous rate of change. Okay, so instantaneous rate of change is the case that the case that's when the amount of change is try to approach to 0. So in this case, what happened? So here's a curve, right? And let's say if point A is here and point B is here, right? So and you wanna find the average rate of change between two this, then you wanna find the slope of the line go through these 2 points. But what if you have the 2 point become close, try to go to close to each other as here and here. So they just like just very close to each other and become in this case become the difference become just like close to 0. All right. So so in this case you have to consider the amount of change become go to 0, okay, but not equal to 0. I'm gonna say that because why? If equal 0, then then this form become what become undefined, right? But we learned about limit already, so that will help you to to find like how it's approached to, right? So in this case, we actually going to use the form as the limits of the form of the of arbitrary chain when the edge approach to zero, right? See that? Okay, so now let's apply that. So number four, I should change this, become example. What's example here? 5. Let me see. What is that example? We have example 5. Okay. Let's say here is example 5, and here is example 4. Number 6. I mean. Okay. I want to find the instantaneous rate of change of the function at the specific self-specified value of x. So in this case, f(x) is equal to x squared plus 4, and x equal to -1. All right. So I have I will always have to find f(x) plus h. What is that equal to? Something square plus 4, right? And that thing is x per h. So now I will have the distribution. You will have x squared plus 2xh plus s squared plus 4. Okay, and now you will have fx per h minus fx, and now you will have what? You will have x squared plus 2xh plus 4, plus h squared plus 4. And then you minus for fx, x squared plus 4. Don't forget the parentheses, right? All the way. And now you're gonna open the parentheses. First one, not change anything. And minus for the second one, change the sign because of negative. So now you can cancel something. Which so this x squared go, this positive 4 go. I mean, I can tell you a secret that mostly the form without h will the form that have term without h will be gone. Okay, so always all the term like x squared, like constant, will be gone. Okay, because this term doesn't have h. So then later I can factor h out, right? So that's gonna be 2xh plus h squared, and I'm gonna rewrite as h times 2x plus h, right? So this is equal to fx plus h minus fx. And now I can write, what I should do, I'm gonna just substitute into the limit of fx plus h minus fx over h, for h go to 0, and it equal to what is that? H 2x plus h over h. Oh, I forgot the limit. Why I forgot this thing. Limits when h go to 0 for h 2x plus h. Okay, in this case, you cannot write with direct substitute, right? Remember that. you have to cancel the edge, because firstly, since its limit, edge try to approach to 0. That means it is not equal to 0. So then you can cancel that, cancel the common factor between edge, and now it's become limits of 2x plus h for h approach to 0. And now I can direct substitute to get 2 times 0 plus, no, not 2 times 0. Why I put 2 times 0? 2x plus 0. And I will get 2x. Okay. Again, what is that? This is like a this is general rate of change, instantaneous rate of change, but it's I haven't, I'm gonna just say like general instant rate of change. So instantaneous rate of change, instantaneous rate of change. Okay. And now I gotta say at x equal to -1, right? We have instantaneous rate of change will be, let me write it down so you know that is instantaneous rate of change equal to IRC equal to 2 times -1, which equal to -2. And that should be the answer of this part. Okay. So if you feel okay, you understand already, you can go ahead and do example 6 here. You can pause my video and finish that, and then compare with my solution after this. Okay, and then now I'm gonna solve it. Okay, so same thing. So always doing f x plus h, right, equal to -2 times x plus h, and then minus for 2. Okay, now this can be simplified as negative 2x minus 2h and minus 2, and then that's going to give me that's going to be the fx per h, right? So I have fx per h minus for f of x. This will be equal to let's copy this down and have parentheses, and then minus for a parenthesis of this guy, close the parentheses, and now I will have, simplify it. I'm gonna, by open the parentheses, I have -2x minus 2h minus 2 plus 2x plus 2. And you can see that the -2x and positive 2x gone, -2 and 2 is gone. Always, you will, you should know that the term without h will be gone after you simplify. So now now it's time to apply into the limit. Have limits of fx per h minus fx over h for h go to 0 will be equal to, oh, actually I should write out this at negative 2h first, right? Negative 2h on the top. Oh, where's the limits? Okay, don't forget the limit, right? Limits for 2h, negative 2h over h for h go to 0. And again, since h is approach to 0, it doesn't mean that h not equal to 0. So then you can cancel the h, and now you will get limits of h go to, of negative 2 for h approaches to 0. In this case, there is a limit of a constant. So that should be the constant, which is negative 2 is answer. Okay? So negative 2 is the answer of example 6. And lastly, I'm gonna do one application, one problem for the application here. I don't even need to cover this, but I think maybe interesting for someone who need it. But if you feel like you're strong already, you don't even need to watch this part at all, okay? So let me do this two example. Say example 7, right? 7. The concentration C of a particular drug in a person's bloodstream is related to the time T in hour after injection in such a way that as T change from 0 to 4. Okay, so this is, say I can say X1 and X2, right? It changed from 0 to 4. And oh no, it's T1 and T2 because why? This time, right? It needs time. So T1, T2. And C change from 0.9 to 0.1. Oh, so it's just give you right away C1, C2. Okay. And find the average rate of change of C with respect to T. Remember that it is a function of CT, right? So you will get, you will have to, you will, you will have the average rate of change will be equal to, let me use form, insert equation, expression here. So I will have C of T1, no, T2 actually, minus for C T1, and then bottom has to be T2 minus T1, right? And this I can easily plug in by the given give us as, okay, so let me copy down. Just give me C2 can be changed to be 0.1. C1 can be changed to be 0.9. T2 is 4. And T1 is 0. So now I'm gonna get 0.1 minus 0.9 will be what? Negative 0.8, I think. So top negative 0.8 and bottom had to be 4. So now this can be simplified as say negative 0.2. Yep, I think so. You can check, let me see. So
0.8 negative, right? Negative 0.8 divided by 4. Going to be 0.2. Yep, negative. So that is example 7. And if you want, if you can still have time to take a look at this example 8, I can help you also. They're actually similar in your XYZ homework. I don't know what problem, but it should be similar with that. So the relationship between the quantities x and y is expressed by the function y equal mx. Okay. The instantaneous rate of change y with respect to x is 2x minus 6. Okay, so I have IRC. Why I don't just gonna using okay, whatever. My pen's crazy. Okay, IRC equal to 2x minus 6. So that's what the given give us. And then they say find and interpret the instantaneous rate of change of y with respect to x when x equal to 2. Okay, so I will have IRC equal to 2x. Oh, so this is in general. Okay, so in general. Right? And at x equal to 2, I will have IRC in the instantaneous rate of change will be equal to 2 times 2 minus 6, which equal to 4 minus 6 going to be negative 2. So this should be the answer for the instantaneous rate of change of y. Okay. Yeah. So this is 2 examples that are similar with the homework. And I will see you in next section. Make sure do the assignment 1.6, and I see you in 2.1 next time. Have a good day. Bye.